We've been given the role of a small manufacturing firm. Using methods learned in ECN109, our task is to minimise costs whilst meeting monthly orders. The inputs given are capital K and labour L. The cost of capital per unit produced is £2 and the cost of labour per unit is £64. The level of output produced is calculated using the Cobb-Douglas production function in the form of Q equals 50k to the power of 0.25, L to the power of 0.5. The monthly orders are 100. To solve this problem, we need to use the Lagrange multiplier. Step 1 is to set up said Lagrange multiplier. G, which is another way of expressing function, starts, followed by K, L and lambda. This equals 2k plus 64L plus lambda multiplied by 100 minus 50k to the power of 0.25 multiplied by L to the 0.5. The next step is to do partial differentiation with respect to k, L and lambda. Firstly, we have dg over dk. This is 2 minus 12k to the power of negative 0.75 multiplied by L to the 0.5 times lambda, which equals 0. Next is dg over dl, which equals 64 minus 25k to the 0.25 times by L to the 0.5 times by lambda, which equals 0. Finally, dg over d lambda equals 100 minus 50k to the 0.25 times by L to the 0.5 equals 0. Now, what we need to do is rearrange to find L. Our first equation is 100 equals 50k to the 0.25 times by L to the 0.5. We can rearrange that to 100 over 50k to the 0.25 equals L to the 0.5. We can then divide both sides of the fraction by 50 to give us 2 over k to the 0.25 equals L to the 0.5. This can be simplified as 2 over k to the 0.25 all squared to equal L, which therefore means that 4 over k to the 0.5 equals L. Now we need to find k. We start with 100 minus 50k to the 0.25 times L to the 0.25 equals 0. Again, 100 equals 50k to the 0.25 L to the 0.5. We can rearrange to 100 equals 50k to the 0.25 2 over k to the 0.25. Written fully, this equation is the same as 100 equals 50k to the 0.25 over 1 times 2 over k to the 0.25. This can be further simplified to 50k to the 0.5 over 2, then simplified further to 25k to the 0.5, which equals 100. If 100 equals 25k to the 0.5, it means 100 over 25 equals k to the 0.5. 100 over 25 equals 4, so 4 equals k to the 0.5. This therefore means that k must equal 16. So now we have 4 over k to the 0.5 and 4 equals k to the 0.5. This means we're left with 4 over 4 to equal L, which is obviously L equals 1. We now need to work out lambda to determine the extra cost of one more additional unit of labour. Already we have determined that 64 take away 25k to the 0.25 multiplied by L to the negative 0.5 lambda equals 0, becoming 64 equals 25k to the 0.25 L to the negative 0.5 lambda, which can become 64 over 25k to the 0.25 L to the minus 0.5 equals lambda. This becomes 64 over 25 times 16 to the 0.25 multiplied by 1 to the negative 0.5. This equals 1.28, which means each additional unit of labour is £1.28.